So, welcome to my video explanation about k-means. The goal of today is to apply k-means to a credit card dataset and then visualize clusters through PCA. The very first thing of my code is to do imports. Here, here what I put is pathlib to facilitate the path, then numpy, pandas as always, and then matplotlib to allow the plot creation at the end of my code. The first function here is load credit dataset. This function basically loads and cleans the dataset I have, which is not a CSV, but it is a ARFF dataset for this k-means example. I spent a lot of time to handle this new dataset. What basically did was it does basically a file reading line by line here in this case. It ignore comments here, then extract the attribute names and start collecting data after the at data here. And then what I decided to do is to transform everything to pandas data frame, just to facilitate the way of the implementation of my code. Then the customer ID column is removed because it's not useful for clustering. As you can see here, is because it's a categorical variable. Then here how what basically I did is to replace the question mark with none. So and then all data are converted to numeric, and then here I handled the missing values. I did this imputation with median because I think that it's more robust than in this case, because in these financial cases all some data are outliers, so the median could be better than the mean. So now let's go into something very important, a very important step in k-means, and I want to justify it super clearly. Basically, in k-means, an important step is to standardize the data and assign points to clusters based on Euclidean distance. Why to do why to implement this piece of code? Basically, because imagine if credit limit, for example, is in thousands, and PRC full payment, for example, is between 0 and 1, then the scale is not the same for these different features. So the smaller feature becomes invisible. It's important here to important so to scale, to standardize my data. In this case, with the standardization, I will have a 0 mean and 1 standard deviation. But in this specific case, I'm highlighting, I'm retrieving the whole dataset standard deviation because it's basically the whole population, and I replace any 0 standard here. I replace any 0 standard deviations with 1 to avoid division errors on custom columns, basically. Let's now focus on this function, which is initialize centroids. Basically, initialization has a huge impact on the results of the k-means. So I decided to implement this initialization through random initialization and through k-means plus. Basically, in random, what it does is just select the k data points. They are the centroids. We call it centroids. It's super fast, but if the points are placed in a wrong way, let's say they are clustered they are clustered all in one area, the algorithm doesn't work properly. So in this case, k-means++ is a good implementation because it's an improvement, let's say, because it spreads the centroids it out. So after choosing the first randomly, so here first randomly, each new one is picked based on square distance. Here is square distance from the nearest centroid. So all the points that are far away are more likely to be picked. And so this could lead to a better clustering, sorry. Then at the very end, I also implemented a NumPy's random generator with a fixed, just to ensure reproducible results. The following function is assign clusters. This is basically the assignment step for k-means. Or what it does basically for each data point here, I compute its distance to all centroids and assign it to the nearest one. Here I used NumPy because I compare all the centroids at once. In this case, I produce basically the distance efficiently without any loop, and then I take the minimum distance with argmin for each point, and this is based on Euclidean distance. Then this other function is about compute the centroids. Very easy because it's the update step of the centroids. So what it does is basically that for each clusters here, for each clusters in the range of a number of clusters, I take all the assigned points and compute their mean to the updated centroids basically. In addition, I handle empty clusters. So if a cluster has no points, I reinitialize it to a random data point. This is crucial because in this way I avoid errors and by keeping the algorithm stable. So now let's focus on k-means. So the function k-means, which is the main loop of my k-mean project. So basically what I did is just initializing the centroids. Here then alternates between assigning points to clusters and updating the centroids till the convergence until the convergence is reached here basically. For the convergence I use two checks basically. If the first one, if the cluster assignments stop changing, or if centroids movement falls below a small threshold. And at the very end, I return the inertia here. Which is basically the total square distance from points to their centroids, which is the objective, the very objective of k-means minimization, and it's very useful for evaluating the different value of k. So then the function PCA2D. Why this function? Because the dataset has 17 features. Yes, 17 features. So I use PCA to project those features into the 2D for visualization. So two-dimensional visualization. So here I compute the covariance matrix of the centered data, and I use NumPy's eigendecomposition. Here the eigendecomposition to get the principal components. Then, since the matrix is symmetric, this method, I can assure that this method is stable. Then I just selected the top two components because they capture the main variance, and then apply the same projection to the centroids so they can align correctly with the data in the plot. Now focus on the main. Well, I prefer to focus more on the output, I would say, but here in the main, what it's written basically, I want to show the cluster sizes, the number of clusters, the method I used, then all the prints to show if it converged, the inertia, and then here, as you can see, the cluster sizes, and then with group by I created this table, which is very useful to show the balance and number of purchases, just to have a deeper idea of what of each cluster, and then with plot, well, with PLT, I would say, with plot. I'm gonna show you a plot very useful that will show you the different cluster position in a 2 dimensions. Now let's run my code. And yeah, it takes a bit. Okay. Here it is, my plot to visualize the clusters through PCA. As you can see, there is cluster 1 in red, cluster 2 in blue, and cluster 3 is the green one. The black stars are the centroids. And here, as you can see, the cluster 1 spreads far to the left, including the main outliers. Then I have cluster 2, the blue one, is tightly packed, I would say, in the top right. Then, as you can see later, they are the lowest activity customers with very similar behavior, all of this. And then I have cluster 3, which is the best in terms of credit card expenditure, which are placed here in the bottom right, and they spread downward, indicating that they have the highest balances and they're more active in terms of credit usage. And then, as you can see, as I said before, the centroids here, the stars, they are set in the center of each cluster because, as you know, k-means places them at the mean of their points. Okay, now that I have explained you the plot, let's go through these numbers. So basically, this output tells us that it's a basically a k-means summary. We have 3 clusters here, the initialization method, which is k-means plus, number of iterations, which are 14, it converged, and in inertia. Then let's go into the interesting part, the cluster size. As you can see, cluster 1 as 35% of the total, with just 3,149 number of customers. Then I have the highest one, which is cluster 2, almost I would say roughly half of the customers, and then cluster 3, just 14% of the total. And but now let's go more in depth by analyzing the cluster profiles. This is the most, I would say, interpretable part. Let's read across the line. Cluster 1. Cluster 1 has the moderate balance here, high purchases, and a decent payment rate. So they are active, yes. They are responsible spenders, I would say. They buy a lot, and they are a good chunk, I would say, yes. Then I have cluster 2 with the lowest balance, the lowest purchases. So what does it mean? That they likely low active. They are not active. They barely use their credit card. This is not a good cluster in terms of credit card usage. On the other hand, cluster 3 as the highest balance and the highest, even the highest balance frequency. So this cluster stands out completely. They are high spenders in this terms. So that's my video. Thank you. That's it. Thank you very much.